India's Navy is undergoing a revolution in firepower and versatility, marked by an extraordinary pace of fleet expansion and next-generation technology transfers. In just the last few years, Indian shipyards have launched and commissioned some of the world's most sophisticated warships: stealth destroyers, modular frigates, sonar-rich corvettes, advanced submarines, and the proud carrier INS Vikrant, all packed with supersonic missiles, integrated air defenses, and digital battle networks. This transformation isn't limited to surface and undersea forces. India has also accelerated its advantage in maritime communications and intelligence through the launch of the CMS-03 military communications satellite, linking ships, submarines, and coastal stations in real time across the entire Indian Ocean. Every induction, every launch, is a step toward a future-proof, deterrence-ready Navy, one that blends relentless industrial growth with cutting-edge science to secure national interests and redefine the balance of power in the Indo-Pacific. Starting in late 2021, INS Vishakhapatnam ushered in a transformative era for Indian naval combatants. Her stealth-shaped hull, fabricated from advanced indigenous steel, spans 163 meters, engineered for minimal radar and acoustic signatures. What sets her apart is not merely bulk or speed, but a fusion of high-capacity sensors, firepower, and real-time data mentored through a next-generation combat information center. Vishakhapatnam's 16 BrahMos VLS cells are embedded below deck, allowing variable warhead loadouts and the flexibility to switch between anti-ship and land attack roles. Each missile employs ramjet propulsion, advanced guidance algorithms, and sea-skimming ingress, achieving both survivability and surgical effect, whether the target is a moving frigate or hardened SSM battery. Her Barak 8 system, 32 missiles strong, ensures not only self-defense, but extends umbrella coverage to adjacent ships during task force deployment. The ship operates 2 multi-role helicopters at any time. She accommodates the Sikorsky MH-60 Romeo, equipped for anti-sub warfare with dipping sonar, torpedo bays, and magnetic anomaly detectors. When in a SU-W configuration, she leverages variable depth sonar and sonobuoy deployment, tying air, sea surface, and subsurface data into the CMS-17A tactical grid. The propulsion is COGAG, 4 Zorya turbines, digitally managed for redundancy and quiet running, linked to acoustically isolating gearboxes to reduce cavitation and thermal noise footprints. Damage control is organized through automated sensors for heat, flooding, and shock. A strategic layout of fire suppression ports, energized bulkheads, and fast seal hatches ensure compartmentalization in case of hit. Advanced degaussing coils run beneath the hull, further lowering the risk from magnetic mines and torpedo homing mechanisms. Weapons are not only numerous, but networked to maximize overlapping fields of kill probability. In close, the OTO Melara 76mm can swap between high-explosive, airburst, and guided rounds, using rapid reloaders to hold off fast boats or drone swarms. 4 AK-630 turrets, radar-slaved, provide the last layer against supersonic, sea-skimming missile attack. The HUMSANG sonar and Najan towed array create an anti-submarine envelope that is constantly updated, shifting launch priority to RBU-6000 rocket mortars or heavyweight torpedoes as dictated by sensor fusion algorithms. Crew comfort and survivability have also taken a leap. Automated safety routines, multi-environment training suites, and secure satellite and VLF-UHF comms connect Vishakhapatnam's command to land HQ and satellites. Modular interior spaces allow for rapid role changes. Helicopter bays can be reconfigured for UAV operations, the bridge can run multi-theater ops, and the medical bay is designed for casualty surge in amphibious or disaster relief missions. Inducted in 2022, INS Mormugaon moves the concept even further. Her bridge electronics, powered by next-gen indigenous processors, feature faster link-up with national and allied networks. With noise-reducing propulsor blades, anti-vibration damping in every machinery room, and heat sinks embedded in her exhaust offtakes, Mormugaon's acoustic and IR signature management put her among the quietest surface ships in the Indian Ocean. She fields instant-on ECM and ESM systems with automated threat correlation. For example, when a targeting radar sweeps the hull, machine logic calculates the waveform, spins up the appropriate jamming pod, and cues decoys or counter-launches without human lag. The ship's aviation facilities were optimized for the latest generation of rotary unmanned systems. specialist launch and recovery platforms, high-rate power and data feeds, and redundancy in both wireless and hardwired drone links allow Mormugao to control multiple rotary or fixed-wing UAVs at once. These platforms undertake everything from off-board jamming to extended-range surface search or submerged mine hunting, multiplying the reach and lethality of her onboard systems. With INS Impul entering service in 2023, the destroyer class becomes even more networked and digitally empowered. Her indigenous electronic warfare racks don't simply jam or spoof. They analyze threat actor behavior, recording attempts at lock, jam, or intrusion, and instantly update threat profiles across the fleet via high-speed, encrypted battle nets. Impul's BrahMos suite is mission-adaptive. Reloading racks are programmable for rapid changeover between block upgrades or warhead types, and Logistics AI automatically tracks missile status, reporting low or damaged stocks directly to dockyards or underway replenishment ships. Impul's Battle Data Recorder not only assists in after-action insight, but constantly beta tests future software upgrades during patrols, keeping the ship and the entire fleet evolvable for emerging threats. The Nilgiri-class modular stealth frigates, starting with INS Nilgiri, define a turning point in escort and multi-mission flexibility. Her hull design reduces radar cross-section using shape, material blend, and M-absorbing coatings. She is, in effect, a stealth escort with a blue water heart. 8 BrahMos VLS cells equip her for precision engagement, while 32 Barak 8 interceptors allow her to screen high-value units or lead in air defense. Underwater, her HUMSANG and hull-mounted arrays partner with RBU launchers and triple torpedo tubes. Varanastra, Exocet, and imported wire-guided weapons are available for every kind of sub or fast-attack craft threat. A hybrid aviation deck launches not just ASW choppers, but optionally, medium-sized UAVs for surface and undersea target data relay. Her CMS enables mission modules to plug and play. Patrol, strike, mine warfare, or humanitarian aid, each reconfigured within hours. For Himgiri and Udajiri, the focus is on AI-enabled battle management, environmental resilience, and multi-channel data feeds. These ships optimize hull design for both hydrodynamic efficiency and noise reduction, optimizing low-speed, high-endurance patrol 1 week and high-speed intercept the next. They stream raw threat intelligence into national fusion centers and field adaptive cyber defenses, updating encryption protocols in response to detected intrusion attempts, then isolating critical systems for attack continuity. On the corvette axis, INS Cavarati is the pinnacle of shallow water hunter design. Her composite hull is nearly transparent to enemy sonar, while triple torpedo tubes and a high-rate 76mm main gun prepare her for high-intensity fights in archipelagos and bottlenecks. Her USHUS-2 sonar and modular ECM arrays are tuned for both diesel and AIP submarine threats as well as stealthy mine layers. Deck modules are reconfigurable for special forces support, drone launches, or humanitarian adjuncts as needed. Cadmat, Kiltan, and Camorta, all commissioned or refitted since 2021, form a triad of high-tech ASW platforms optimized for Indian coastal and island chain security. Each leverages advances in acoustic quieting and array blending, with mission management systems able to process multi-static and passive intercepts, interpolating sub-position and movement within complex sea lane traffic. These corvettes, apart from weaponry, operate as digital relay points, transmitting, amplifying, and forwarding encrypted battle commands from flagships to patrol vessels far down the chain, guaranteeing command resilience even under concerted jamming or missile attack. INS Vikrant, commissioned in 2022, is a floating operations center, a sovereign island, and a strike base. Her flight deck adapts to rapid turnarounds for MiG-29K fighters, fielding sorties from anti-ship strike to aerial cover, while MH-60 Romeo helicopters extend anti-sub reach hundreds of nautical miles from the hull. The bridge, laden with next-gen C4I systems, blends battlespace images from horizon to horizon, feeding instructions to every platform in the strike group. Defensive layers consist of the Barak 8 network, multiple CIWS mounts, ECM pods tuned for both high-speed and low-observable threats, and hardened backups for power and flight control in the event of catastrophic damage. Flight operations, logistics, comms, and maintenance routines are fully digitized, making Vikrant an adaptive, self-correcting centerpiece for multi-domain Indian task forces. INS Ikshak, entering in 2025, transforms the role of the modern survey vessel. She isn't just drawing charts. Her side-scan sonar mosaics, AUVs, echo sounders, and digital current profilers feed live data back to operational HQs, giving real-time environmental advantage to submarines, amphibious groups, and undersea drones. Built for rough seas and complex littorals, she supports rapid minefield mapping, seabed clearance, and safe passage for confidential task groups, becoming an information edge ship in modern sensor-driven naval warfare. Beneath the surface, the newest Kalvari-class submarines now stand as the backbone of India's diesel-electric underwater fleet. Completed and delivered since 2021, each hull employs anechoic tile coating and a fine-tuned hull shape that dissipates sonar pings, making them ghosts in contested waters. Their air-independent propulsion system is a leap. Lithium-ion batteries and fuel cells allow weeks of operation, silent and submerged, without exposing the boat to periscope-depth hunting by adversary aircraft. Inside, 6 heavyweight torpedo tubes can field Varanastra and imported torpedoes, Exocet anti-ship missiles with pop-up final attack modes, or precision-laid self-propelled mines for area denial. Kalvari's digital sonar suite manages not only active and passive search, but can run real-time threat libraries, plotting course corrections to evade or intercept enemy submarines, and possessing ultra-high fidelity data up the command chain for coordinated wolfpack attacks. The periscope blends high-res day-night sensors, ESM intercepts, and secure burst communication links, letting the sub stay hidden but connected for coordinated strike of hunter-killer groups. The Arihant-class SSBNs, strengthened and expanded in silent numbers during these years, exist purely for deterrence. Their shrouded reactors give them weeks or months of underwater autonomy. Each missile silo can be loaded with K-15 or K-4 missiles, their warheads and range covering the entire tectonic sweep from Persian Gulf to the South China Sea. Their hull form suppresses noise below background ocean levels. Their communications are encrypted, burst-based, rarely surfacing, and always unpredictable in pattern, so the second strike promise always holds. At a system level, Arihant boats integrate with new national satellite relays for recalled orders, but run with sealed protocols. Crews are trained for total autonomy, able to execute strategic retaliation even if the rest of the fleet is affected by cyber or kinetic shock. Digital twins of major warships, running on shore-based server farms, simulate damage, fatigue, and resource consumption in parallel to real-world operations, allowing for predictive maintenance, precision refits, and more tactical flexibility in the heat of deployment. Crews in these modern hulls experience a new reality. Training simulators on every big ship let junior sailors and officers test for battle damage, electronic attack, or cyber intrusion scenarios. Medical bays use telemedicine and robotics to handle casualties when evacuation is impossible. Mess decks employ improved rotation, better noise and climate control, and facilities for lengthy, high-tension blue water sorties. Bridges function as fusion centers, where live feeds from radar, sonar, UAV video, and satellite comms merge on wraparound displays, letting combat decisions be made at the pace of digital war rather than the limitations of manual plotting. In every exercise, these fresh hulls have proven their worth. Destroyers and frigates launch missiles and reload at sea. Corvettes and patrol boats run high-speed interception and amphibious support. Submarines simulate kill shots on enemy convoys, then vanish to fight another day. All the while, the fleet's intelligence, logistics, and C4 ISR chains churn together. Fresh data, fresh tactics, fresh crews blending to create a living, evolving navy that wraps its strengths around new threats. Should India's navy ever need to unleash full power, the newly inducted fleet offers an unprecedented mix of deep endurance, shock strike, and operational autonomy. The adversary would face not one, but dozens of simultaneous dilemmas. Lines of BrahMos launches from sea and below, air defense barrages weaving a wall around high-value units, submarine holocausts in choke points using stealth and shock, with logistics and data outpacing, refitting, and rearming the battle edge as fast as engagements unfold. Carrier aviation, fleet air defense, and digital integration have reached new heights with INS Vikrant at the center, redefining how India projects and protects maritime power. Vikrant hums with activity from dawn to dusk. Her pilots and deck crews coordinate precision fighter launches, jet recovery, and helicopter sorties with clockwork regularity. MiG-29K fighters dominate the sky, equipped for both anti-ship strikes and air superiority missions thanks to upgraded radar, electronic warfare pods, and a weapons suite so adaptable that loadouts can pivot from guided bombs to air-to-air missiles in a single rotation. The carrier's MH-60 Romeo helicopters deploy dipping sonar, acoustic buoys, and flash torpedoes in concentric sweeps hundreds of kilometers ahead of the fleet, creating an invisible net that detects, tracks, and destroys enemy submarines far from the carrier hull. The ship is protected at every moment with layers of hard and soft kill measures. Barrack 8 vertical launch arrays, powered by next-gen active guidance and fire direction, switch instantly from defending the carrier itself to expanding area defense for the whole group. AK-630 mounts employ radar and IR overlays for autonomous, last-ditch interception, putting up curtains of metal against saturation attacks. But what makes Vikrant unique is the integration of all fleet assets. Every radar ping, every enemy missile launch, every drone takeoff from another ship is processed and displayed in her Combat Information Center, fusing threat data, coordinating countermoves, and queuing joint weapon launches. Unmanned aerial systems are now central to defensive and offensive operations. New high-endurance UAVs operates from Vikrant, destroyers, and OPVs, relaying persistent sensor images, tracking surface and air contacts, and delivering electronic jamming to blind or confuse hostile radars. Shipboard drone bays can rapidly switch between surveillance, strike, and decoy roles, handling multiple mission types without changing major hardware, improving responsiveness in fast-moving battles. The carrier's maintenance infrastructure is modular, with smart robot arms managing flight deck munitions and digital logs helping engineering teams trace effects from wear, heat, and fluid pressure. Advanced engine monitoring includes predictive diagnostics, warning technical crews if critical part replacements must be scheduled or if temporary workarounds can be run on new software. Vikrant's telemedicine suites relay casualty information to shore bases or support vessels, ensuring medical teams have exact readings and can deploy advanced interventions even while far from India's coastline. Support ships that have entered service during this period form the logistics backbone of all distant operations. These hulls carry enough fuel, weapons, aircraft spares, and food for months of roving operations, using multi-node underway replenishment and smart asset stacking. Helicopter decks are adapted for supply drone launches, while semi-autonomous warehouse robots speed up the loading and sorting of cargo. Their own defensive weapons, including close-in autocannons and short-range missiles, make every auxiliary ship a surprisingly tough customer in contested waters. New drone-centric doctrine means even non-combatants now field offensive power. Fleet support vessels can queue anti-ship drone strikes or launch sub-hunting UAVs in tandem with destroyer groups. Data received from the most advanced hydrographic vessel, INS Ikshak, is instantly transferred across the digital mesh, letting logistics assets plot safe approaches or steer clear of new undersea hazards. This reduces risk when approaching mined or contested zones, improving both speed of battle group movement and survivability. Task Group Command has been transformed by integrated C4I suites aboard every major hull. Data from satellites, shore installations, aircraft, and every ship is fused in real time, letting commanders visualize not just ships and aircraft, but electronic and cyber threats, sensor gaps, and even weather fronts that might affect missile paths or aviation recovery. Artificial intelligence wargame scenarios, queuing recommended formations, firing solutions, and evasive maneuvers, letting tacticians focus on the human elements of command and the judgment needed to adapt to enemy surprises. Ashore, Indian Navy training centers match the pace of fleet technical growth. Crew assigned to new hulls endure advanced virtual battle scenarios, simulated missile attacks, network intrusions, rapid refueling cycles, and damage control against fire, flooding, or chemical hazard. These rehearsals mean that the moment a new ship takes to sea, her crew is already steeped in best practice doctrine, familiar with emerging tactics, and prepared for the unpredictability of multi-domain war. If called to strike as a force, the post-2021 fleet can overwhelm any regional opponent, not only through the volume of fire or endurance of hulls, but by orchestrating battle on the speed of information. Ship and air group launches would be sequenced with drone barrages, submarine wolf packs, real-time hydrographic intelligence, and coordinated defensive wall building, creating a battlefield where every tactical move had multiple upwarding options, and adversaries were forced to react rather than act. With the last wave of modernization, the Indian Navy has created a fleet that doesn't just keep pace with technological change, it drives it. At every level, from command to the waterline, the Navy's new structure is tuned for rapid response, deep endurance, and simultaneous control of air, surface, and subsurface space. Amphibious and special forces capability has surged as new landing ships and multi-role platforms join the inventory, supporting interventions from disaster relief to island capture. Modern landing craft now embark on support hulls, fitted for rapid deployment of marine battalions and armored vehicles. Their bridges control high-bandwidth drone swarms that scout beaches, mark minefields, and direct precision strikes ahead of troops. Fleet defense has become a balance of electronic supremacy and hard-kill redundancy. Newest hulls integrate quantum-resistant encryptions on their data links, and onboard cyber cells train continuously against simulated and real digital intrusions. Every major ship operates with real-time network health monitoring, shutting down compromised nodes or rolling over to backup systems mid-battle. Electronic warfare suites are able not just to jam, but to deceive, replaying enemy sensors. Own signals back to them in a confusing echo that conceals Indian Navy movements. Crew welfare and combat readiness come together in the new generation of smart accommodation. Climate is actively regulated, with noise and light control for round-the-clock shifts. Galleys use optimized meal planning, and recreation spaces carry integrated VR domes for physical and tactical training alike. Even aboard auxiliary ships, medical facilities now support advanced trauma care, rapid diagnostics, and robotics-assisted surgery, all critical for extended blue water operations where rapid medevac isn't an option. The Navy's new command structure exploits every ship's connectivity. If one hull is hit or isolated, its mission and sensor data are automatically taken up by others. Should a scenario arise where a dozen destroyers and frigates, fresh corvettes, a carrier, submarines, and support ships go into coordinated action, the result would be defense in depth at every axis. Dozens of BrahMos, launched by air and surface platforms within moments of each other, would destroy or disable enemy airfields, fleets, and logistics centers. Barrack 8 and CIWS networks would shred incoming retaliation. Carrier aviation would control the air, striking deep inland before an enemy could recover. Submarines would sink any reinforcement or try to split retreating enemy groups. All the while, support vessels, an often underrated backbone, keep the battle line supplied, steaming, and fighting for weeks on end. Whenever a command node is lost, a new one emerges seamlessly from the digital mesh. New survey vessels like INS Ikshak guarantee the battle group never loses its bearings, even when moving at speed through unknown or contested waters. In practical terms, the Indian Navy's new class of ships, submarines, aviation assets, and auxiliary fleet now provide the country not only with the ability to secure its coasts, but to control critical trade corridors, deter adventurism, and shape the outcome of regional conflicts before they escalate. Each induction from 2021 to 2025 has acted as a force multiplier, incremental in itself, transformative in combination. The sum effect is not simply a larger fleet, but a thinking, linked, living combat organism formed by layer upon layer of indigenous technology and constant adaptation. Every missile tube, every helicopter blade, every fiber optic cable and sonar pulse is shaped for the realities of tomorrow's war, a war where whoever commands the seas commands the outcome. India's Navy, with its new warships, stands ready not just to meet that future, but to define it.